Why are the trig ratios called what they're called? Okay, we'll just do the basic ones. Okay, well, kind of. We'll do sine, cos, tan, and we'll do sec. Okay, so we had a look at where did I put my where'd it go? Oh, there it is. We had a look at these with regard to right angle triangles. Okay, and sure enough, that's where their kind of definition is. They start as ratios, right? But these are more than just ratios. I said to you, okay, sine, which that's actually an abbreviation. You guys know it's actually sine. Sine comes from a word that means curve or curved, right? Where does it come from? Well, if, and this should be a little bit familiar to you, if you take the values of sine x and compare them to values of x, and if you plotted them on a graph, just like we plotted, what does x look like, and what does x squared look like, and what does log x, etc., etc., etc. Okay. If I take values from say 0 to 360 degrees, okay, and you plot out, all right, what's sine of 0, and what's sine of 45, and sine of 90, and on and on and on, right? The shape that you get, if I plot all of these different angles, right, you get this curvy shape, right? We call this a sinusoidal curve, okay? So sine, its name, comes from this shape, which comes from, if you were to test out all of the values for all of these different angles, then these are the sines of those angles. Okay, so it's curvy, right? Cosine. I really, really hope that at least some of you, actually I know for a fact that some of you know what the co in cosine stands for, because it also is an abbreviation. What's the co stand for? It stands for complement. Very good. So this just means the complement of sine. Complement as in adds up to 90 degrees rather than complement as in, hey, nice haircut. Okay. So what does this mean? If you take an angle like 30 degrees, we know what sine 30 is equal to. We were just talking about it, right? Well, whatever it's equal to, it will be equal to the cos of the complement of that angle, right? And you can go ahead, you can redraw the triangles to test it, right? In the same way, if you take any angle you like, then its cosine, right? The cosine of the complement of that angle will be the same. So that's where it comes from. You might think, oh, is it really that useful? Well, by the way, you can see why. When you draw the triangles, right? If you make a theta down here, and you don't know what theta is, it could be 30 or 44 or whatever you like, then clearly this opposite angle over here is going to be 90 minus theta, right? So right from there, you get your definition, okay? If I call this, let's see, well, our traditional names for sides in a right angle triangle, right? If I take sine theta, that's opposite on hypotenuse, which is B on C, right? And if I take cos of the opposite angle, cos of 90 minus theta, right? That's going to be adjacent on hypotenuse. So that's why they're the same. Okay, so there's sine, there's cosine. Where does tan come from? Or more specifically, where does tangent come from?